All right, so our last main option for what we can see when two players run into each other. Again, we need to know the total momentum just to see the basic gist of the outcome. We've got M1 V1, M2 V2, so the momentum from each player. And what's special about this one is now we have a different kind of collision. So the ones we had before were called elastic collisions. So think elastic like rubbery, stretchy, bouncy. That's when things run into each other and then separate again. But this one is inelastic. So they don't bounce away, they leave together. So, in football, if somebody's trying to make a tackle, they would hope that to wrap up and take the person down. What's going to happen here as far as how our math goes, they end up moving as if they're a new combined object. So their masses literally go together. So use that word to stress and help you remember. But the masses go together there in parentheses. And then we don't know how fast they're going to end up going, but they have to be going the same speed. Because again, together it means they're matched up, linked up. One person's basically carrying or holding on to the other person. That actually makes this one a little bit easier to solve again, kind of like question 5, just with a bigger mass at the end. So you'll notice that we don't have two separate velocities and quite as much information to track. Once more, because of the way the velocity is meters per second, we're guaranteed to get meters per second. The kilograms all match each other, so we're not worried about the units there. We just want to work down and see what kind of an answer we can get. So we have 150, then a positive 1.92. Seems like we keep getting that number. And then 106, that's another repeat. These aren't as random as I'd hoped. 81.29, that's new, minus 1.29. Then the masses get combined. Again, they move together, add the masses together. We're looking for the total mass of what is now like a two-person object, which is a little bit awkward to talk about, but it's how it's going. They're moving at the same time. All right, so this velocity at the end is what we're looking for. We want to simplify where we can. So combining the masses, we get 256 times that velocity that we still don't know. By now, you should be good at calculating a total momentum. If you have to, find this part, find that part, and subtract them. If you're careful, you can do it in the calculator all at once. Either way, you should get something like 151.26. And then to end up solving for this velocity, we want to divide by that big mass there. Because again, remember, it's two people moving at the same time. Together, they're overall heavier. We get 0.59, and because it's a velocity, meters per second.